Hello, welcome to the electrical engineering class. The last time I was trying to demonstrate a short circuit and power outage, blackout happened. Honestly, I didn't expect it. Okay, let's think what happened with this diagram. So this is this circuit breaker. Let's say CB1, and rated trip current is 5 ampere. And I create short circuit on purpose by this bridge wire like this. There are no load, no resistance, it's short circuit. And I don't know how much current flow this short circuit, but let's assume 1000 ampere was flowing this short circuit, for example. It's just hypothesis. And of course, 1000 ampere is much greater than 5 ampere related current. So I expected this circuit breaker will trip. But as a result, other circuit breaker let's say circuit breaker 2 was tripped. And so this power supply, this circuit breakers, this power supply comes from this room's outlet. So let's say this is outlet, and this circuit breaker 2 is protecting this outlet and of course other load, including this room lightning. So yes, this room lightning and maybe another load like as an outlet. And unfortunately, this circuit breaker tripped, caused by short circuit I made. So this room light also power down and blackout happened. I guess 5 ampere. This circuit breaker 2's rated trip current is 20 ampere. I confirmed. I guess 5 ampere tripped first because 5 ampere seems sensitive than 20 ampere. Let's think. So if this horizontal axis is the magnitude of the current, and so 5 ampere and 20 ampere, CB1 and CB2, if the short circuit is 1000 ampere, short circuit is happened and it's increased from 0 to 1000 immediately. So if think about only this factor, the magnitude of the current, 5 ampere was tripped first because the short circuit reaches here first and here. But as I mentioned at the first of my video, the selecting protecting device, including circuit breaker, not so simple, you know. So some people just care, including me, just care about this rated current, rated trim current. But there are another condition like time characteristics and interrupting capacity, you know, that depending on the percent impedance, something like that. So in practical designing, we needed to conform the manufacturer to detail specification of each device. Let me explain those stuff maybe another video. So anyway, please be careful when you treat electricity, especially for short circuit. Okay, so next failure is overload. In this video, I've mentioned about this motor load so far, but this motor is just rotating himself. That means does not have any works, you know. In the first place, the definition of load is something to do as well work. So the typical motor load is like a pump or compressor or something that combined with motor and do something work. So think about pumps. Pump is just as name pry, pump up something, process fluid, like this is motor like this, and pump combined motor looks like this. This is pump, and pump up something this pipes and pump up something process fluid. And okay, let's think this example. This pump are working to pump up water, okay? But okay, some okay, some foreign substances like this mix in pipe, looks like this. And what happened next? If substance stuck inside the pump, what happened? A pump is trying to move, that doesn't work because of this substance getting caught. And even this state, motor are still attempting to rotate, trying to rotate, but it doesn't work. So that makes this state makes current increase. Right, so okay, think about this motor. When this motor is rotating, if I hold the motor shaft like this, a motor is still trying to rotate, but there are some resistance, my hand. So this state, I think motor need more energy or power or torque or something to keep rotate cause of this resistance. This state is overload, and overload makes the load current increase. So why overload makes current increase? Let's think with the induction motor's formula. So capacity of this induction motor is 0.2 kilowatt. Rated capacity means the maximum work this motor can do. So let's say the power also sought capacity equivalent square root 3 because this is a 3-phase induction motor times voltage times current times power factor, and let's fill each value. So the maximum rated power is 0.2 kilowatts, so 200 watt equivalent square root 3 times 200 volt and current, and power factor is 0.8. So let's say the current equivalent get 0.72 ampere. Let's see the rated ampere, 0.7, almost same. So if some failure occur and this capacity required by load increase, this capacitor increase, let's say voltage and power factor is almost fixed value, they can't change, so it's fixed. So that is because the current is needed to increase for overall working. Okay, I don't know, but maybe current will be like the 1 ampere or 1.2 ampere, something like that. The point is it exceeds the rated current. This state, there are possibility that motor burn out because of current change to zero heat. The manufacturer does not guarantee the safety with such a overcurrent. So if overload lasts for a while, the coil heat up and some failure will occur, like insulation failure or coil interrupt or coil short, or just thermal and mechanical breakdown. So this is why protection device is needed, like thermal relay that can prevent by detecting the overcurrent some predefined value. So if they setting the 0.7 ampere, if overload happen and the current exceed 0.7 ampere, it's overload, so they can they detect such a failure state and interrupt for safety. So if we want to monitor overload, you can use this ammeter. So you can observe the value of the current. In the control circuit, each protection device like circuit breaker and thermal protection relays, they have different loads respectively. So circuit breaker is mainly installed to prevent a short circuit, and the thermal protection relay is mainly installed to prevent overload. So okay, let me stop today's lecture, and the next time I will explain the ground fault. Okay, thank you for watching in this video, and see you in the next time.